dear students, welcome back to mathsc.com. This is your Joycey ma'am. Today we are going to learn few more activities, the continuation of the chapter Circle, Class 10 Math, NCERT and Theorem 10.1. Are you all ready? Shall we start? Here we go. Children, I told you the relation between the circle and a line. There are three possibilities. And the relation between the secant and a tangent. How the tangent becomes the special case of a secant. That we have seen in our previous video. Now we are going to learn how many parallel tangents that the secant can have. So my circle is this and I am going to have my secant. The secant is PQ. My finding is I am going to find how many parallel tangents this given secant can have in a circle. What am I going to do to get my parallel tangents? Of course, you know the tangents will happen on the circumference of the circle. It doesn't happen inside the circle. So, I am going to draw parallel line on either side of the secant PQ. Draw lines, draw the lines, draw the parallel lines. I draw and you can see at what point this parallel lines become the tangent and it touches the circumference at one single point. So I can understand these two are the parallel tangents for the given secant PQ. Now you must have your doubt why ma'am is drawing parallel lines. Of course, we should not draw the intersecting lines or any other zigzag lines. Why? Because it is about parallel tangents. So the parallel tangents I can get only by drawing parallel lines. And it's not that I'm drawing on one side of the secant PQ. Instead, my finding is, my observation is, I'm going to find whether I could get at least two parallel tangents on either side of the secant. So, I'm going to drawing the parallel lines on either side. If I'm drawing this side, I'm having possibility to draw the parallel lines on the other side of a secant PQ. So I draw the lines and you can see those lines come and touch the circumference at one single point and at that point these parallel lines becomes the tangent for a given secant. So what we can understand is for a given secant there can be maximum of two parallel tangents. Now you will have a doubt, ma'am, I can draw a tangent at this point here and at this point here. So I have four tangents. Of course, in a circle there can be infinite number of tangents, but that's not the concern here. My context is how many parallel tangents that the given secant can have. I can have this tangent and to this tangent parallel tangent is this one and this tangent to this tangent the parallel tangent is this one. So these two are the other two parallel tangents for the other secant. Maybe that secant can be AB. So this tangents will not be parallel to a secant PQ. Hope you understand this clearly. So, if not, suppose the PQ is not given, the secant is not given, at this time, you can say a circle can have maximum two parallel tangents at a time. So, it cannot be more than two parallel tangents. Of course, you must understand there can be infinite number of tangents to a circle. But how many parallel tangents? The parallel tangents may be at the most two. So you must have understood by this activity how many parallel tangents that the secant can have. Now we move on to the theorem 10.1. 10.1. Before going to the theorem 10.1, I would like you to understand the activity or the understanding of this concept. Actually, children, math is nothing but observing what is happening around us. That is what math is. Now, you must have noted some of the people riding a bicycle. So, if not, at least you have to observe hereafter some are riding the bicycle, and you can see the bicycle have two wheels. Consider one wheel. That one wheel is nothing but a circle here. So, of course, circle means it will have a center, the first thing, and the radius. The circle must have a radius. It will have a radius. Now, what is the radius in a wheel of a cycle? I understand the spokes are nothing but the radii of the circle. So, of this circle that I consider. Now, how these spokes will be in a wheel? The spokes are like this, and it goes like this. And you must note this point also. When you ride a bicycle and you are riding on a road, that road is nothing but a straight line. You can imagine that road is nothing but a straight line. So the wheel is rotating, revolving or rotating on this road. Now you can